Bismillah ar-Rahman ar-Rahim. Today we will talk about granulation. As you remember, granulation is not, the intent is not to get granules as a final dosage form, even though we have some preparations in which granules are the final dosage forms. But here we are emphasizing that it's an intermediate step in order to make tablets, and in some cases also to fill the granules or pellets into capsules. Okay, so why we are doing granulation? طبعا there are many reasons, but as intermediate step, the most important reason is to prevent segregation. What happens when you mix different ingredients together? They tend to segregate, if you remember, according to size, which is the main factor, or density, or shape can have also an effect. The other reason why we are making granules is to improve the flow property of the powder mix or the granule mix. When you have larger granular preparations, they flow better, and this is important when we want to fill the cavities in the tableting machine in order to compress them into tablets. The other reason is to improve compaction characteristics of the mix. In most cases, just mixing the powders, filling them in die cavities of the tableting machine does not result in compacted tablets with sufficient strength. So making them as granules will provide them with such characteristics اللي هي compaction characteristics. طيب, you will learn that we have different types of granulation. Maybe you already know about the dry granulation. If you remember, in dry granulation, we have the roller compaction, and we have also the slugging method. And we have with the wet granulation. In wet granulation, if you remember, we have the fluidized bed granulation, but also we have the shear granulator and the high-speed shear granulator or mixer. Okay? But what you did not learn about before, we can do granulation through melting granulation. Okay? So we have a mixture containing certain polymers, and when they are in a higher temperature, like 60, 70, 90 degrees, they will melt, and eventually you will break them into granules. So here we have three types of granulation process: dry granulation, wet granulation, and melt granulation. In melt granulation, I have to add here that they usually use it when they want to control the release of the drug from the granules or from the prepared tablets. Okay, so there is a controlled drug release. Also, you need to know the mechanism by which granules form, what influence the granule structure, and therefore their properties, what make them compressible. Okay, now what we talked about here, okay, except the last point, you will see them summarized in the following video, so please pay attention to the following video.
Welcome to LFA's video on granulation. There are three reasons to granulate your formulation. 1, to improve the flowability of your formulation. 2, to make your formulation more compressible. And 3, to ensure a consistent spread of API throughout the formulation. One way to test if your tablet formulation needs granulation is to check your formulation's flowability. A way to do this is to test the angle of incidence. A small angle on the powder will show good flowability, meaning it's suitable for direct compression. A high angle means your formulation may need granulation, as it would not flow well and may potentially cause arching, bridging or rat holing within your tablet press. We have a video on the angle of incidence which we'll link in the description below. Direct compression. In tableting, sometimes your tablet formulation needs neither dry granulation or wet granulation and can be directly compressed. This is the most cost-efficient process within tableting. Your API and your excipients needed are taken and added to a mixer. Once blended, they can be compressed in your tablet press with no further steps. This is a great option for sensitive APIs that may be sensitive to both heat and moisture. However, it needs to be mentioned that you should consider mix validation to ensure your tablet formulation has been mixed the correct amount and not too much. Please see our video on mix validation in the description below. Granulation. Granulation is the process to produce larger granules, remove fines, and to improve the flowability within your formulation. There's both wet granulation and dry granulation, but before granulation you first have to complete your formulation, including both API and excipients, minus the lubrication. Dry granulation is a combination of granules without the need of any liquid. Dry granulation is generally used if your formulation is sensitive to moisture or heat. Let's look at slugging, which is using your tablet press to form large tablets that vary in weight due to poor flowability of the formulation. The slugs created are then put through your granulator to be broken down into granules and then compressed once again for your final tablets. Whilst reading about dry granulation, you may have also heard of roller compaction. Roller compaction is where your formulation is fed through a roller compactor. Your mix is fed through the top hopper, where two rollers will compact the powder to form a ribbon. This would then pass through a granulator where the powder is forced against the mesh, which creates the granules of the desired size. Whilst being one of the most complex forms of granulation, wet granulation is one of the most popular due to it being applicable to most formulations with the purpose to cause aggregation of particles. The adhesive, usually called a binder, is incorporated in the form of a solution or suspension in a suitable liquid. The liquid should be non-toxic and is preferably water, although other solvents are sometimes used. The fluid bed granulator is one of the easiest forms of wet granulation as it all happens within the same unit. Hot air is fed into the bed, lifting the granules whilst they are sprayed. The granules bind together to form bridges between themselves. The initial phase of wet granulation is the spraying of the granules. The spray rate is dependent on your formulation. Next is the wetting of the powder, begins to form liquid bridges between the granules. The process is continued until the required size granule is formed with solid bridges between the granules. Once complete, your granules will go to the drying process. The spraying process is turned off and the hot air will continue to flow through the bed, drying the granules. There's many different machines and processes for wet granulation, such as fluid bed granulators, planetary mixer granulator, and rapid high shear granulators. After both wet and dry granulation, milling is needed to delump and create a standardized granule distribution. After milling, complete your final blend whilst adding lubricant. The lubricant is added after to coat the final granule, which allows the formulation to flow easier through your press. Whilst LFA doesn't supply all of the equipment mentioned in this video, we do have a list of recommended suppliers that we...
Okay, so what you heard about is summary of actually this topic. It's very summarized. It doesn't include everything. For example, it doesn't talk about wet-free, water-free melt granulation. It doesn't talk about many things, but at least you learned a summary of this topic. Now, direct compression is the easiest, most forward, includes the least number of steps, and of course you will learn about the tableting before, after maybe 2 topics. But the problem is not all powder mixtures are directly compressible. They will have also usually poor powder flow and also segregation. So the reason why it's not applicable to everything is poor flow, ingredient segregation, and inadequate compressibility. That's why we tend to go for granulation. In tablets formation, okay, where the granules are compressed, they need, in order to uh, bind together and form this coherent tablet, a deformation has to happen, and this deformation will help in bonding, okay, and it will help in creating a tablet with integral structure, okay. So when we say deformation, deformation is talking about changing the shape of the granule so that it will have more contact areas with each other. This is what I'm going to show you in the next slide. You will see here the granules, and when they are compressed, طبعا the spaces between the granules will be less, and the shape of the granules will change, creating more contact area, and therefore structure integrity of the tablets are obtained. Okay. طبعا when we say deformation here, we are talking about plastic deformation. Plastic deformation means there will be a permanent change in the granules shape. Unlike the elastic deformation, where after applying the pressure and then removing the pressure, the granules will retain its original shape. No, here we have a permanent change in the granules shape. It's very important that the granules are not very hard. If they are very hard, it will be difficult to change their shape. And also they should not be soft, because soft means they will not only cause sticking and picking in the tablets, and these problems you will learn about them later on, but also the tablets will have a low structural integrity. Okay. Okay. Now, regarding granule production. Okay. Regarding granule production, the most important maybe thing is whether we are using a liquid or not. Okay. طبعا when we use a liquid, this is the most commonly used method, اللي هي wet granulation, which you will learn about it later. This is the most common method, okay, because it's applicable to most formulation, as you learned from the video that I showed you earlier, okay. So the most commonly used method is the wet granulation. But when you have a problem of sensitivity to moisture and heat, you will resort to a method that is not using liquid, such as dry granulation and melt granulation. So that's why we can classify granulation to wet and dry method. طبعا after adding the diluents, the disintegrating agents, and other ingredients, necessary ingredients, except طبعا lubricants, as you heard in the video, lubricants are added at the end just before tableting. So after you add these ingredients, you might want to add an adhesive, or we call it a binder, in a dry form if you're going to do dry granulation. The binder or the adhesive will help in the process of allowing the particles to stick to each other. Okay. In wet granulation, the binder or adhesive is dissolved in the liquid and then added to the preparation to do the wet granulation. Let's now dig down into dry granulation method. It's actually applicable to moisture and moisture sensitive and thermolabile drugs, materials that can be affected by moisture, and by heat, because you know that in wet granulation you have to do drying after that. Okay. Why we are doing that? Okay, the reason is, as we already discussed, granules are important to obtain good flow and good compressibility and to prevent uh, segregation. طيب, how do we do that? There are two methods. One is called slugging to produce slug, and the other one is roller compaction to produce ribbon that will be broken after producing the ribbon. Okay. After breaking the ribbon, it has to be sieved in order to get the desired size. Now, slugging is a traditional approach. There is a problem with slugging. You will learn about it later. After slugging, I have to break the slugs with a high force, and usually it will be difficult to recompress the granules again. That's why a gentler method, roller compaction, it's continuous and result in a uniform densification. Unlike the slugs produced, some of them can be weak, some of them can be hard, and this is one of the problem. Getting into wet granulation, the liquid that we use has to be volatile because you need to dry the wet mass, and it has to be non-toxic. One of the things, or some of the things you will take into account, the cost, the safety, and the drag stability when you are choosing your liquid. So liquid is very important. But what liquid do we usually use? The liquid that we usually use is water, and this is the most common. Why water? It's cost effective, it is safe, but it lacks it may lack the drug stability when water is present in the mixture. That's why if there is such problem, then you go for ethanol or 2-propanol. Now the problem with ethanol and 2-propanol اللي هي الcost with safety. Maybe it's good for drug stability, but we have a problem because these are volatile, very volatile solvents that can cause explosion. So you need some kind of safety if you are going to use them. طيب, do I necessarily need, with the solvent, do I necessarily need an adhesive or binder? No, not always. Sometimes the liquid added to the formulation in itself, some of the ingredient will dissolve in the liquid and will cause the adhesion at the end. So it can be a solution of adhesive or binder, or it can be just a liquid, and then the ingredients in the formulation will cause the binding, or will act as a binder. Okay, especially those that dissolve in the liquid that we are adding. طيب, how does granulation method affect granule structure? You will learn about many different ways to produce granules. Conventionally or traditionally, the granules will be sponge-like matrix of binder, but again, it depends on the method of preparing the granules. For example, in spray-dried system, it will be spherical particle. The outer shell will contain the binder, and the inner core will have particles or air. As we already talked about, بالنسبة للsolvent الادvantages بتاعتها والdisadvantages، وبالنسبة للorganic solvent as we said, we can use it when we have water sensitive drag. في عندنا one of the method to produce granules اللي هو fluidized bed granulation, and this one produces high porosity granules, and the surface of the granules will have the binder film as you will see here. This is wet massing conventional method. You will see that the binder is distributed all over the granules, while in fluidized bed and similarly in spray drying, you have most of the binder on the surface. Okay, now we will talk about the mechanism and how particles bond to each other. Now, usually, and this is important in dry granulation, for dry granulation, usually you don't have moisture, or sorry, you don't have water, it's dry, but you have what we call residual moisture. Yani any powder will have some moisture. Okay, most of the powders will have some residual moisture. This residual moisture, we call it immobile liquid films. Okay, this can happen. اللي هو immobile liquid films can occur after you are drying wet granules. You are drying it, so there is residual moisture. We call them immobile because they are not in large quantity to allow them to be flexible and move here and there. They are adhered to the surface of the granules. In this case, we have what we call adhesion cohesion. If there is more liquid في granules, then you have what we call mobile liquid films. Also, طبعا we are talking here about the mechanisms of bonding. So bonding because of the presence of immobile liquid films or because mobile liquid films, but of course, eventually these granules are going to dry. So these are temporary forces, interfacial forces, temporary forces, while the granules are wet when you are doing wet massing. Another type of bonding with solid bridges. Like after you dry the wet mass, you will start to have, instead of liquid connecting particles, the dissolved material will form solid bridges. We have also attractive forces between solid particles. This is a normal thing. It can be electrostatic forces, which is not very important. Maybe it's important during mixing. And the more important force اللي هو van der Waals forces. Okay, these cause particles to mechanism of particles to connect to each other. These are kind of permanent forces, unlike اللي هو mobile liquid films. When you allow the particles to come very close to each other, this will increase van der Waals forces. And we have the mechanical interlocking, and this is because of the shape of the granules. They can lock into each other, causing them to be close to each other. So let's talk about each one of them. اللي هو adhesion and cohesion في immobile films. As I said, this is very thin. It's immobile layer. It's usually after drying the granules or when you have a powder with some residual moisture. The main force of attraction is van der Waals forces, and you should know that van der Waals forces are proportional to particle diameter and inversely proportional to the square of distance, to the square root of sorry, to the square of the distance of separation between the particles. This indicates that the distance is very important between particles. And you know that in dry granulation, what do? We cause the particles to come very close to each other, and this will cause the particles to adhere very well to each other. Okay? What does this mean? When the distance becomes smaller, the van der Waals forces becomes very strong. Okay? It's even more important than the particle diameter. Regarding the interfacial forces in mobile liquid film, this applies to wet granulation. And I want you to see here the different stages. You have here separate dry powder before wetting it. And when there is a small quantity, or initially, you have what we call pendular state, and you have the liquid bridges here. And when the spaces and pores becomes less between the particles, or the distance becomes less, you have what we call funicular state. And the more liquid you add, you have capillary state. And you have suspension state, but this state is only important when we are talking, for example, about spray drying, because in spray drying you have suspension or solution, and you will form a droplet, and this droplet will eventually evaporate. So this is not important in conventional or traditional wet granulation. So you have these three stages. The capillary stage, you see there is no spaces between the particles, but the particles are not completely surrounded by liquid, such as in the suspension stage, which is only important in, as I said, in spray drying. طيب, how do we get from one stage to another? Okay, طبعا this can happen by two methods, okay, that I want to talk about. One is adding more liquid. Okay, so you add more liquid, and the liquid will start filling the spaces between the particles. But the other way is through kneading or mixing the mass. While mixing, the particles get closer to each other, and this can result in densification. Yani, when the particles become closer to each other, they will eliminate these spaces between the particles, causing it to reach the capillary stage. Okay? What you know is capillary state, the forces between the particles are 3 times that of the pendular state. You want to reach this capillary state. So two factors can affect that, mixing, kneading the mass, and adding more of the binder solution. But you know that these are temporary forces. Eventually you are going to do what? To dry them. And when you dry them, you have what we call solid bridges. Solid bridges are not only happening because the liquid dries here, causing the solid bridge. Okay, solid bridges can happen because even for the dry granulation, when you dry the granules, when you compress the powder together, you have some friction between the powder particles, and this friction causes heat, and this heat can cause partial melting حتى في dry granulation, partial melting. And when you remove the force and the heat dissipate, the temperature goes down, they will harden. They will cause solid bridges between the particle. إذا solid bridges is not only because of the binder solution has dried. In that case, we call it hardening binder. Okay, it can happen also for dry granulation when partial melting happens between the particles being compressed, and this partial melting solidify, so it can cause bridge. And the other way to cause the bridge, solid bridges, any material that dissolve in the liquid, whether it contains binder or not, because you know that we can cause wet granulation by liquid alone. So anything in the formulation that dissolves in the liquid will crystallize and will form the solid bridge. So this is the summary of what I talked about. طيب في dry granulation, we talked about electrostatic forces during mixing. These electrostatic forces will cause initial formation of agglomerates, but more importantly, when you cause the compression and when you cause the particles to come very close to each other, van der Waals forces will become significant. They are 4 orders of magnitude stronger than electrostatic forces. So in dry granulation, the compression will cause the van der Waals forces to stick the particles to each other. It's very important that when you add the binder solution to note the following: that if any material in your mixture, in your formulation, dissolves in the liquid you are adding for wet granulation, especially when we are talking about the active pharmaceutical ingredient, we call it API, if it dissolves and then you dry the granulation, drying will cause recrystallization, you know that. And if these crystals are large, this will cause low dissolution of the unit dose or of the granules, and this will cause, of course, lower absorption rate. So you have to pay attention to that. If you are adding a liquid that dissolves the API, your active pharmaceutical ingredient, then drying can affect the crystal size, and this can affect the dissolution of the granules and the tablets if you are making tablets out of the granules. Type, how does the granule form and grow? There are 3 stages. We have the nucleation. Here you have few particles stuck to each other. You have transition, when the nucleus nucleation grow larger, and you have the ball growth when it becomes much bigger. Okay, so let's talk about these stages. Transition can happen when single particles, they come to each other, or now we want to talk about the nucleation. When particle and particles come in contact with each other, and this can happen in pendular state. And as I said, if you densify the particles, they can go from pendular state to funicular state to capillary state, forming a nucleus. Isn't nuclei will form when you have few particles sticking to each other, few individual particles. Amma transition, when you have 2 nuclei coming and joining each other. This can happen by pendular bridges, where when 2 nuclei join each other, they will become bigger. We call it transition stage. Or individual particles, they stick to the nucleus and bipendular stage or bridges, and this will make the nucleus bigger. Ball growth is further growth. This can happen when more particles join to form a bigger wet mass. Here you have some of mechanism by which granules form. For example, here you have two nuclei getting to each other, forming a bigger one. Here you have drug particles and excipients. The excipients causes while mixing causes the particles to stick to them. Here you have what we call abrasion transfer, where the excipient will take some of the drug particles. Layering, this is a special mechanism where first we are forming nuclei from excipients, and then we are adding to them the drug particles. We call it layering. And coalescence, breakage, abrasion transfer, and layer. It's very important that when you do granulation, you recognize the granulation endpoint. So you should not overmass or undermass wet mass powder mixture. As you remember, we said we don't want the granules to be very hard or soft. Okay, so there is an endpoint. It's very easy with modern machines that do granulation very fast that you do over massing. Yani more wetting can happen. Okay, let's talk about industrial wet granulation equipment. We have the shear granulator اللي هو normal ones that are used in granulation. These are very slow and you need many equipment. Maybe in the video you saw in the beginning, you saw they are talking about normal shear granulator and there is a high-speed granulator. The traditional shear granulator, the very important or very famous equipment is called the planetary mixer. Okay? The problem with such equipment, you will have an equipment for mixing and another equipment for granulation, planetary mixing. This will cause loss of materials, more time, more investment, etc. More efficiently, we have the high-speed mixer granulator. The high-speed mixer granulator, as you will see here, you have a propeller here to do the mixing and a chopper here. After adding the wet solution to the powder mix, this chopper will work in order to cut the wet mass into granules and eventually discharged here. The very important equipment is called diosna mixer or granulator. Diosna is important because this is a famous equipment. This is a trade name. It is high-speed mixer granulator. Okay. Let me just show you this one, high-speed shear granulator, how it works.
what you have seen, the mixing is happening in the same device, in the same equipment. Wetting is wet massing or adding the binder solution is happening in the same design, cutting it, and without drying. طبعا there is no drying step here, but after that it gets discharged, and when it's discharged, it is also possible to cut further the wet mass to make sure that you have the granules. So you will have wet granules. After that, you need drying. So the advantage here is the speed, and second advantage, everything is done except drying. Everything is done with the same equipment. After drying or before drying the granules, we may subject the wet mass or the dry mass into oscillating granulator. You will see here, you add the moist powder or even the dry powder into oscillating granulator that moves back and forth, and then it is forced through the sieve. The sieve here, screen, determines the size of the granules that come out. We have also the fluidized bed granulator, and I think you saw that video in the first video. The nice thing about fluid bed granulator is that everything is done with the same equipment: mixing, wetting, drying. So everything is done with the same equipment. The major disadvantages, it has or it needs a lot of optimization. Initial cost is high. It needs a lot of optimization. If you change the formulation, you need to do optimization again. And in this table, you will see that optimization is needed for the apparatus, for the process, for the atomization itself, and for the product parameters that you need to apply. This is the fluidized bed granulator. Here you will have your powder mass, and binder solution will be sprayed, and everything is happening in the same equipment. We talked about granulation endpoint, and we said that one of the biggest challenge is when to stop, because you don't want to over wet or under wet your granules. And to overcome this problem, we will have sophisticated monitoring equipment such as impeller torque. Yani, what does it mean? For example, if we go back to the high-speed mixer granulator, we have a sensor to measure the resistance to its rotation. And this resistance will determine how the wet mass, or what point the wet mass has reached. Okay, so we have حكينا اللي هو sensor for impeller torque, or something to measure power consumption. How much power do I need to put in order to allow the propeller or impeller to work? We have specialized type of granules, spherical granules or pellets. This is especially important when we are filling capsules. If you look at many of the capsule products, you will see that they are filled with spherical pellets. They are having the advantage of excellent flowability compared to conventional granules, and reproducible packing, which means that you will always be putting the same amount inside the capsules. They are very important when we want to manufacture controlled release dosage forms. That's why Whenever you hear about spherical granules or pellets, you have to think about controlled release and about capsule dosage forms, uh, 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 because these pellets will have good flow and good packing inside the capsules. The equipment that can produce such thing اللي هو spray dryer. If we want to make tablets, spray dryer is able to produce granules with good compaction properties. The reason is the binder is surrounding the spheres or the granules. Usually these granules are hollow spheres. Hollow, yani from inside it's space. Why this happens? Because after you spray the droplets or the solution or the suspension, the liquid will evaporate. So how does it evaporate? It evaporates from inside to outside. So from inside it becomes hollow. Right. So we have spray dryer. We have special type of equipment called spheronizers or pelletizers. How this is done? It's done by extrusion, spheronization equipment. اوكي يعني في عندنا one way اللي هو extrusion اول first extrusion and then spheronization. طيب, how this happens? You will see here some different types of extruders. This is an axial extruder, screw feed extruder, or the auger extruder. This rotates, forcing the wet mass through small holes. في عندنا radial, في عندنا gravity. We have also the piston type. طيب, after these are produced, what happens? You will see cylindrical granules. But what we need is spherical granules. So what happens? We take these cylindrical granules and we put them in spheronizer. That's why they call it what do they call it? Extrusion, spheronization, two process, more than one equipment. Okay? While this rotates, okay, طبعا air will be coming from the edges here to dry the preparation and also to cause toroidal motion. حلقي يعني toroidal motion. This toroidal motion will keep bumping into the edges of the cylinder, making it go through different stages until you have spheres. This is how spheronization happens. We have an equipment that can do everything in one equipment. Okay? Not multi-steps, not multi-equipments. It's a single step in one equipment. You have what we call rotor granulation. And this is what you see. You have air coming from the edges. You have granulation happening or wet massing happening because of sprayed solution. The base here is rotating. Okay. Powder first gets into this rotor base. It gets mixed. Granulating liquid is sprayed. And at the end, you have drying air coming in. While this rotating, it causes the spheres to fall. What are the advantages and desirable properties of the spheres? The shape and size is uniform. It has excellent flow. We already talked about that. It has reproducible packing. We talked about this. Also, this is an additional thing, is that it has stronger mechanical strength. That's why these spheres do not break easily. So they have low friability, and that's why it's more suitable to add it inside capsules, not to compress it into tablets. Also, the surface of these spheres or pellets is smooth, and this will allow good coating if we need to coat the pellets or spheres. The last type of granulation, after we talked about wet and dry granulation can also happen by melt granulation, where we do not add any liquid. So it's suitable for drugs susceptible to hydrolysis. Okay, but it should withstand temperature, because the temperature can increase to 60 to 90 degrees Celsius. So in this process, in addition to the drug and other excipients, we are adding a polymer. This polymer will act as a binder between the particles when it melts or after melting solidifies. Okay, and this polymer is also important to control the drug release. شفتوا كيف؟ So it's a binder controlling the drug release. For example, we can use the water soluble binder if we want immediate release, such as PEGs, or hydrophobic binders such as carnauba wax, stearic acid, and other fatty acid derivatives if we want a more controlled release or slow release preparation. How do we do the melting? It can happen with hot water jacketed vessels that increases the temperature of the formulation, or it can even happen without that through mixing and agitation, where agitation causes the temperature to increase, reaching, for example, 60 degrees Celsius in as little as 10 minutes. The limitation of this process اللي هو we don't have many materials or many polymers that we can use for such process. Okay, but the advantage اللي we do not use any liquid. Okay, this is what you see. Okay, regarding the dry granulation, we already talked about slugging and roller compaction, and we said that the problem with the slugging, ايش هو البروبلم? We have many problems. We said each slug will not have, or the densification of each slug is not uniform. The compaction is not uniform. The reason is when we are doing slugging, there is segregation and the flow is bad. And this will cause the densification to be variable between different slugs. And because we are applying high pressure for slugging, something called a property known as work hardening will happen. After the slugs are produced and then you are breaking them to smaller granules, they will have poor recompaction. When I take them again for compaction into tablets, they will have poor recompaction. That's why here you will see the slugging, طبعا in very simplified drawing. Slugs are produced, high slug. You will see 25 millimeter diameter, will height 15 millimeter, and then they have to be broken, and here you have the granules. So as I said, it has slugging is nowadays less used. A gentler method اللي هو roller compaction. Now it's used more frequently compared to ايش? Slugging. This is roller compaction. But the most commonly used method اللي هو ايش؟ wet granulation, because it's applicable to most formulations. خلينا نشوف. Let's look at the roller compaction. We already saw it, but let's look at it again in individual video here. You will see the ribbon is produced. هذا ribbon. So it goes to a milling with CV to produce ايش؟ the granules. So it's avoids work hardening that happens with slugging and allow the deformation to happen when we are pressing the granules again to making the tablets. Roller compaction is more economical. Compared to wet granulation, applies to wide range of material, but not all materials. Okay. Investment cost is relatively low. Scale up, يعني from small scale, laboratory scale to large scale is an easy process, not like, for example, fluidized bed degranulator. The properties of the granules are uniform. They have similar mechanical strength. If you compare it to ash, to slugging, I know slugging, I told you some of the slugs will be very hard, some of them will be ash, not very hard. The reason is the bad flow of the formulation before we make slugging. Because of gentle squeeze of the powder formulation, work hardening problems that happens with slugging is avoided. By that, we complete this topic, and inshallah we'll see you in the next one.